Okay, let's get to the main part. We delete this one, and because I think I haven't been clear enough before, this version I'm using is not the default Blender version, it's a BMesh build from graphical.org. You don't have the BMesh, we don't have the BMesh branch yet in the default Blender, so we don't have this new knife tool, we don't have the dissolve edges tool, we don't have any of that. You need to go to graphical.org and download a BMesh build. So, having said that, let's see how we're going to create this piece right here. Start with a simple plane, as always, as in all the examples. Grant Warwick. I like the fact that he starts really simple. Maybe I should take a lesson from that. We have selected one edge on the side. Let's extrude it upwards somewhere like that. Extrude it again. Create a sort of a curvature. And again, start and go the other way. And again, the last flat piece. Right there. So we end up with pretty much this, whatever it is, a curved surface. So if we subdivide, smooth it out, turn this off because I don't want the subdivided surface to be shown in edit mode. It's just a personal preference. I like to work like this in edit mode and see the result when I just press tab. So right here, let's divide this piece. So far I'm not changing anything, it's just like the example you can find by Grant Warwick. The credit is all his. Where the difference starts, I'll let you know. We delete those faces. We extrude this edge on the x-axis so it reaches the other part. And we create this quad again, so we now have a mess with all quads again. Normalize it and smooth it out again because because Blender doesn't do that automatically. And we have a pretty undefined mess. We have to define those edges so that are not blobby and all that smooth. Again, because we have all quads, we can and pretty much set up loops. We can use the edge loop tool right here, on the other side too. I have this predefined. See, now it's really sharp. And at this point again, create an edge loop. Alright. So, something like that. What he does, because he doesn't want all these lines right here, he takes these vertices, merges them at the center. You may have noticed that I've changed the shortcut here. I find it very confusing to use Alt-M all the time. It's just not that convenient. I don't use layers that much, so I've replaced a button at the top of my keyboard. It's very easy to find a key that's above your usual keys, F, G, R, whatever. Not the Alt-M, I don't find it useful at all. It has to be one key. And then he selects these loops. Just a little bit of a tip right here. If you would choose dissolve, we get this result. We could have been at the edge mode and dissolve those edges, which would do the job, but it would leave the vertices behind. See that? They're still here. And they could mess things up and not produce a quad mesh at the same time, which is not what we want at all. So we have to go to vertex mode every time, select what's left, and select to delete edge loop. This will delete the edges as well. I think we would have done it in edge mode too, right? Yes, select this, select edge loop instead of dissolve, whether in edge or vertex mode. I was wrong about that. And we are left with a clean quad. Well, at these parts. So dissolve edges is very useful. As I've already explained, but it leaves behind the vertices. We have to choose edge loop so that the vertices go away. Simple? I think so. We select this edge right here because we have two triangles. Notice? Because of the loops we created, we have three triangles that we don't want at all. We dissolve this time because we don't want any of the faces, the vertices, to go away. Still want this one, still want this one. And have a quad. It's a nice mesh. Again, let's define the upper and lower parts. This point right here and this right here. Good, it's starting to get a bit more orthogonal. And for the most important part, we'll create that that crease, whatever you want to call it, that lane. That will be the point of our interest. I want to scale that to the x-axis, the y-axis, so that it's a straight line. Create another edge loop, and now we have an edge loop that will give us the corridor that we want. We're gonna split this, lower this part. I got near to what we want to achieve. It's the first step. Let's define this the way Warwick does it. Define from the inside. Good, so we now have a clear, crisp corridor. You could run water through here, I suppose. It's pretty nice. So, how do we steer it? Well, this is the part that Grant Warwick doesn't explain at all. He's a pro modeler, I get that. He does what he does by instinct by now. He has a lot of years of experience. So he works by saying, I can exactly explain what I'm doing, but follow along and you'll get it. Well, it would help to explain it a bit better, Grant, but thanks. I try to do my best. So, I believe in simplicity, so we'll get rid of the definition loops that we did right here. Remember how we selected edge loops? Right here and right here. So this corridor is blobby again, it's undefined, but it is simpler. It is simpler. It has two polygon loops, this one and this one, not four loops. So that's where the magic happens with BMesh. I can just cut whatever I want, wherever I want. So let's start by defining where we want the new loop to go. Say we want the end pole. Remember the end pole that will define the inside of the curve. We want it to be here because we want our loop to turn here, quite right there, and we want the end loop, just try to keep it simple, we want the end loop to be somewhere around here. This will be the outside of the curvature, right? So far so good. So let me use a little help from a grease pencil. We will want our loop to go all the way from here as it already does. Yes, and somewhere along this point and right here. It's pretty simple. We've created the new loops, the new edge loops from the outside loops of the mesh. So let's define the inside too, so that we have a full corridor. It doesn't matter if they're exact, really doesn't. So let's say we want to straighten this up a little, not all of them, just these. Scale them up on the x-axis by 0 so that they're all straight. I do that by pressing the middle mouse button after pressing the C, the circular selection. I scale again on the x-axis, they get a little bit straightened up. And again on the outer piece. No, I need to select that again, thank you. Scale on the x-axis, right there. Maybe I need to straighten these out because the cut wasn't so accurate. But it doesn't matter, many of these will be rectified as we go along. So, we pretty much know what we want to do right now. We want this piece to turn right here. So, remember what I said about non-adjacent edges? Say we wanted to go from this edge right here. Ignore the adjacent edges that run along. We would probably want to have another edge right here, and then somewhere around here, and around here, and around here. It's pretty simple, right? So, how will we get this edge? Well, this edge would come out like that. Oh, I'm still at the grease pencil functionality. So, that edge right there would come out of this vertex merged with this vertex at the position of the last one. See? There's a vertex. Just like magic. This one, then we go to this one, this one, this one. It's an edge loop again. But we have some garbage along the way. We have this edge loop that we don't want, so delete it. All this part of an edge loop. See? That's the edge loop right there. At least the outside part of our gutter. We need to define again the inside. So, again, we would have to have an edge here, another edge here, another edge here or so. You get the idea. This would have to be the direction of our edge loop, right? So we would do it again the very same way. We would take this vertex and merge it right here at the position of the last one. And just like magic, there's our loop again. We delete the garbage in the edge loop. So here it is. One edge loop, two edge loops. When we go to object mode, we see that we have to lower some of the vertices. So I copy the Z position of this vertex, which is low enough, and I paste it to those two things. Let's select so we can see it. See? Now it's turned. Remember the theory about N poles and E poles. The N pole is here, it's just a vertex that is connected to three edges, 1, 2, 3, and the E pole, the outside pole of our loop, is right here. It is connected to 1, 2, 3, 4. 4. It is connected to 4 because this is an N-gon right here, and we have to cut it. So let's do that, so it doesn't create any weird pinches. So we have again quad here, quad, quads everywhere, and the E-pole is right there, the outside of our loop and the inside of our loop. Just a beauty. So let's define it again. An edge loop right here, and another one right here. Crisp and clear again. It was just as simple as that, but without the extra layer of complexity that Warwick uses on his mesh. He does something that I will explain on the next video. He doesn't get rid of the first two edge loops that define the loop better, that make it crisp, and he works on all the edge loops, which makes things a little difficult to understand. I hope you get the example so far. I'm gonna make another video that explains, that makes these steps again with the extra loops, because they have a little bit of complexity, an added complexity. So I hope you enjoyed the video this far. It may be enough for you to understand the example. Maybe follow all of the examples of Grant Warwick. They're all excellent. They all are free education, and I admire that. A pro of the industry, giving us examples of how to create building blocks. I think this is very important, and that's why I'm doing this piece right here. Thank you.